Hey, everybody, and welcome back to another episode of Adventures in Machine Learning. This week on our panel, we have Ben Wilson.
Hello.
I'm Charles Max Wood from Top End Devs, and this week we're going to be talking about basically communicating between like front-end apps and back-end data science ML setups, which I think is kind of a merging of our two areas of expertise. So this should be pretty interesting, right? Because just to give a little background, you all have heard Ben talk about what he does most of the time. Of course, you've transitioned more into kind of engineering lately, but for my end, just to give people a little bit of background, I've been doing Ruby on Rails development for the last 15 or so years. And then I've been getting into front end. I've done a little bit of all of it, right? I've done a little bit of React, a little bit of Angular, a little bit of React. I think I said React. A little bit of Vue. That was the other one I was trying to think of. I've done some mobile development. So, and that's what I get paid for, right? I get paid to build web apps. And so, yeah, we were talking and Ben had the idea, and I really like this. We're probably going to have to figure out how to not talk past each other, which is probably part of the problem that a lot of teams have, right? When they run into this problem is, okay, you have some kind of information that I need, right? Mm-hmm. And, on my end, I need to make the application do something or display something or, whatever. And so, yeah, how do we make them jive, right? Because ultimately, they're paying for a system like machine learning or data science, right? So that they can use it for things, right? And sometimes there's like business analysis or something, and so you just you display it on like a dashboard or something. But sometimes it's like a prediction engine or something, right? And it's like, okay, well, I want to intelligently tell people, hey, you watch this movie on Netflix. Why don't you watch this other movie on Netflix? Because we think you'll like it too, right? And that's a little bit different animal, because it's not just, oh, well, here's some data, right, that we're going to display, but it's actual behavior that's based on the data science or machine learning. So, yeah, so how do we make my stuff talk to your stuff? Hey, folks, this is Charles Max Wood from Top End Devs, and lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv, and I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com.
Yeah, I mean, I couldn't have put it better. And that's the struggle that I've had with the first couple times that I had to build a solution that's interfaced with the wider world. Data science is a back-end process for the vast majority of things. Yeah, you do produce visualizations, but when you're talking about machine learning, your algorithm is outputting predictions, and that those data structures, whether you're serializing it to disk or pushing it to an LTP server or whatever you're doing, the structures that are within our internal tooling for data science work are optimized for that back-end processing.
Right.
Not so much when you're pushing it across the wall to serving. The output from ML algorithms, sometimes it's a Pandas data frame. Sometimes it's a Spark data frame, depending on what platform you're running. Some algorithms are NumPy arrays, which is a specific wrapper of Python implementation of a traversable, iterable collection. And front-end apps don't generally play well with those data types. So there's some conversion that you need to do in order to hand it off. And the struggle happens when a team is working on doing something, like, say, with your example, the prediction project that you're trying to do. You're saying, hey, you've watched these 17 movies across these 3 genres. We're going to recommend the next 20 movies for you to watch that we think you'll like. The output of those algorithms coming out in the structures that they are, you can't just say, okay, I've got the pandas data frame, I'm going to save it somewhere and then have the front end pick it up. It doesn't work that way. You're either going to serialize it in a particular format, or you're going to write it somewhere that they can read from directly. It's going to be fast and meet SLA requirements. But what I struggled with the first couple of times that I did these, and I've seen so many companies struggle with as well, is they come to the realization that it doesn't work for the front end a month before it's supposed to release to production. So they might have spent 6 months, 9 months, or a year working on all the back end stuff. They're focusing on the model. They're focusing on making the predictions as good as they can be. They might be exercising proper software development practices. They might be doing Git branch strategies with all their changes. They're tracking everything in MLflow. They're doing everything right for the data science tasks. But then they assumed that the front end would just do magic with whatever they produced. And that exactly happened to me. The first, actually 2 projects that I did like this. And the front end developers, basically in those roles, was like, Ben, like, what the hell is this? Like, I can't actually deserialize this data. And I have no idea what this structure is.
Yeah. So just to throw a few things out, sometimes the magic can happen, right? So you're talking about like pandas data frames or Python something arrays or something. So if this is a common enough problem, then what can happen is I'll go and I'll look in NPM, right, for JavaScript, or Rails in Ruby Gems, and I'll see if there's something that can just read the data frame, right? Because then all I have to do is say, grab that and get, and then I can say, okay, I need this data, I need this data, and this data, right? And it basically handles all that stuff for me, right? And so I look like a magician, but in reality, I just found a library that will do the magic for me, right? I did a little bit of research, and usually there's enough of a code example for me to say, and that's what I need, right? But in other cases, that's not the case, right? And some of this stuff is new enough or is evolving quickly enough that no promises, right? And so then it's, okay, do I get things in a manner that I have to parse, or is there some way that you can do something in a way that is already standard to what I do?
Yeah, and the struggle that I had with those first couple projects, and I see people struggle with, not so much the reading of the file, because that's what the front end devs did at both of those.
Yeah,
for those projects, they're like, we can read it, but the data structure is not ready for us to consume it. Like you have it in this denormalized, exploded view.
Right.
It's basically like a pivoted table in a database, but we actually need it to be fully denormalized. We need it to be a primary key, and then all like a key, and then an array of arrays that explain we need an array for each place on our app to display that content. What you gave us was a member ID or a primary key of the user, and then another key that is item number, and then a value that is their affinity to that thing. They're like, we have to now do a bunch of transformations in order to create this data set, and we don't have the SLA budget to do that because you just gave us 17.3 trillion rows of data. Like we can't look that up that fast.
Right. I mean, you basically handed us a whole database.
Yeah. Yep. And you've got 70 milliseconds to return that collection.
Right. Yeah. Yeah, exactly. Well, the other thing is that, just to give a little bit of context for machine learning and data science folks who haven't done web or mobile development, when you're building an interface, just to kind of simplify what's actually going on, because there's a lot that goes on, right? It's usually down to like behavioral stuff, right? So it's when you click this, it does this, or things like that. And you don't have to worry about any of that, right? The people who are building the app are going to handle all that stuff, right? But when they're looking for data from you, effectively what they're doing is they're trying to get the information from you so that they can fill in the blanks on the UI, right? I mean, that's really what it looks like, right? And if you get a list, then you fill in the blanks by saying, we're filling it in with this list, and we're just doing it over and over and over again for each thing in the list, right?
Yep.
I mean, that's about as complicated as UIs get from the data standpoint, right? And then if there's interaction, then we may come back and ask for more data, right, from whatever data sources we have. And so when we're building, I mean, that's how most of that works. And so then the rest of it is what has to happen in the back end to make all of this stuff useful, right? So then it's we're gonna put this file here, right? So we're gonna do this with an image, or we're gonna munge this data in a particular way, or and so the rest of the stuff on the back end, we're gonna process this data into a report so that we can display it, right? And so there's all the building for read operations from a user standpoint, and then there's all of the processing from the write operations from the standpoint of the user, right? And everything, and that's the rest of your app. And so from there, what we're really looking for is, hey, data science folks or ML folks or whoever, right? We're looking at you as another data source. We need to fill in these blanks. What do we fill them in with? I mean, that's what we're asking for.
And I think, it gets even more complex with that, the burden on the front end engineers when we talk about business rules logic that has to go on.
Right.
Like sometimes you can do that with the data science predictions. For pre-computed values, you can put some logic in there. It's like, hey, we want to, if we're recommending movies, we want to have something that looks at the user's history. If they really watched one genre a lot and then they just stopped watching it completely and shifted to a new genre that's their favorite. So that temporal relationship, there may be business rules that say, hey, if we detect this, then don't recommend the old stuff because their tastes have changed. You can do that on the data science side before you generate those predictions. But then there's going to be business rules that there's no way you're going to handle it in data science code. It's either going to be too complex, it's going to add too much to your runtime, or it has to change so fast that making those code changes and validating them on the ML side is going to take longer than it would be to do it on the front end side, because the front end devs writing JavaScript are going to be far more agile and have higher velocity at changes than an ML team. So
I'm imagining
some of those rules,
a couple of things, like for example, parental controls, right? So you make video recommendations, right? And then, I'm going to go through it on the parental controls and say, that has this in it. Nope. Right? Because the parents turned it off, right? That has this in it. Nope. Or this is a kid's account. So I'm going to take your results and I'm going to say anything that has bigger than a PG rating is gone. Right?
Yep.
And so, stuff like that. But that filtering may happen on my end, not your end. But we have to talk about that first, right? Because
exactly.
There may be a better way to do it, right? You may have a better way to do that than I do, right? Where it's like, well, we could just build a kid's recommendation engine that does a better job of it. Or maybe what you're saying, it's like, no, it does an excellent job if you take all the recommendations and then just drop out all the adult content.
And that's what you just explained was 2 experiments that need to be run on the back end side and like working with the front end side.
Right.
But the point, like the plot of this discussion is there's no way the data science team is going to know all of those details or even know the most efficient way of trying it without having that conversation with the front end devs, which is why the earlier that conversation happens, if you're building anything that's going to be going into an app or a website that's going to have user interaction, what I recommend to everybody now is day one of project planning, before a single line of code is written, before you have a broader discussion with the rest of the business, there should be internal meetings between front end devs and the ML team, and maybe the back end devs as well, who are going to be handling like payment processing or whatever core aspects of the app that might touch that data in any way. There should be days, if not weeks, of meetings and discussions and brainstorming sessions to do exactly what we just did in real time, which is like, hey, age content filtering, that's important. There's going to be other filters that are going to be applied and then fallback. Like what happens if you're hitting the REST API that the ML engineering team is is providing to get that content for that user, and the request time's out, or you get a 500 error. There has to be a cached value for generic fill-in, because the last thing you want on that app is to just have a blank pane of like, oh, I guess the content's not loading today. It's got to be filled with something.
We recommend nothing.
Yeah. You might like blank.
You watched all the good stuff, all of it.
That would be funny, actually. I know people who probably should get that recommendation on Netflix because they watch so much of it.
Yeah. But no, I
you need some fallback. Yeah.
Mm-hmm. But the other thing is so you sit down and you define, okay, this is how we expect this to work. Keep in mind that you probably ought to be doing some form of agile process that says,
yes.
And when that doesn't actually go to plan, right, we're going to talk about it. Because at some point you're going to figure out, oh, well, what we're getting back isn't exactly what we thought, or this is just not as effective as we envisioned, or hey, this process of getting results or displaying results or processing results takes way longer than we thought it would, right? And so then you need to go back to each other and go, okay, well, it's taking us too long to process the results we're getting from you because it's 1.7 trillion things in the thing, right? And JavaScript just isn't that fast at that, right? So we need you to help us pare it down, right?
Yep.
So you either need to give us a smaller data set or tell us what we can ignore. And so then you start having those conversations, right? But the other thing is that beyond sort of the upfront conversations about, hey, here's how we intend to talk to each other, right? And settle on some kind of data structure that you can both use. So you're either going to use some kind of library that allows you to use the data source they expect, or you may just settle on something that's common practice like JSON, right?
Yep.
And your teams can figure that out. I'm not going to preach one way or the other because honestly, my guess is that probably most of the time you can get away with JSON or something, but your situation may be different. And I don't want you to go, well, Chuck said we could use JSON. And so we're going to die trying to make JSON. No, talk to each other, right? That's the whole point. But the other thing is, and this is something that I advocate for on every project I work on in software, and that is that set up a deployment as soon as you can, right?
Yep.
Get this out there where you can go and actually make them integrate, right? Because if it talks in theory, then it doesn't talk, right? If they don't talk to each other in actual practice on actual machines or virtual machines or containers or whatever you're using, then you don't know if it actually works. Okay. And if you have a Docker Compose setup with a model and hey, it works here, I mean, that gets you a ways down the road, but it's still not the same as a deployment that looks like what you think you're going to be doing in production. And then you can start having the conversations. Hey, when we hit the REST API, 1 out of 3 times it times out. You're just not going to see that until you actually are using a system that looks like what you intend to deploy
exactly
in production. So get that out there. I mean, you're sitting there going, we're a month out and we don't know if this works. And I'm going, what have you been doing? Right? I mean,
working on the model.
Seriously. It's funny because I start Rails projects for different things. And one of the first things I do is I deploy an app. And literally, if you went to the app when I deployed it, it would show you the screen that says, welcome to Rails, right? Because that's the setup. But then I know it runs. I know it works, right? I set up the background job processing and run a couple of things through that because then I know it runs. I know it works, right? And then I can start writing things in there and going, okay, now I need it to send emails. Does it send emails, right? Now I need it to connect to this third-party thing. Does it connect to this third-party thing, right? And it's the same thing with these data systems or machine learning systems. Is it up? Is it running? Can I talk to it? Am I getting data back? Do I know what to do with it? And if you're hitting that early on, then you can solve a lot of these problems before you have these monster issues come up and creep up on you last minute.
Yeah. I mean, I really could not have said any of that better. I could just expand upon confirming what you just said as the way to go with ML projects. About a year ago, working with a client, and they were like, all right, we want to do recommendations. And I'm like, okay, cool. Where's it going? They're like, well, it's going, we're going to be hosting it on 2 different versions of our website. and we need it on Android and iOS. Like, cool. All right. And they say, well, how are we going to get started? What are our recommendations for the ML side of the house? And I was like, we're not going to do that yet. We know that those algorithms work. I've looked at your data. You're collecting the right sort of data to solve this problem, but we're not concerned with that. And the conversation rapidly moved into, all right, let's get a prototype. We're going to mock up exactly what this is going to look like with the front end. And just to show that you can populate that frame in the budget that your CTO wants. And the requirement was, hey, this pane has to load in less than 200 milliseconds. This was actually on the apps. It was, you have to scroll down basically a page to actually see that. So they're like, hey, you got some time for that to populate. But the data science team, they freaked out. They're like, we can't get that done in 2 weeks. Like, well, we won't have the data. Like, nobody cares what the data looks like. We just want to see it show pictures and text of something. And they're like, well, okay, we can just send them, we can just send this one array over there. And I'm like, no, that doesn't test for scale. What we're going to do is we're going to take a random collection of product IDs, and we're going to take the full list of your customers, and we're going to just randomize that array for each customer. And then we'll log in in the QA environment, log in as these synthetic users. And that way we're going to see what that response is. And then we're going to test it automated for 100,000 requests in an hour and see how this thing actually works. Like, does it function the way that we need to with basic logic? We're going to put some filtering on the fly of that return value. And that project got into production in just under 6 months because when the model was ready and all those requirements were baked into the predictions, the front end knew exactly what data was coming. They had their aspects. They had been testing in parallel to say, well, we can do the content filtering for age appropriate, or say, oh, this content shouldn't be recommended to this type of user in this geographic region or something. So they were working on all that magic. So the data science team was working on relevancy. And when it came time to do the final QA, there were no architecture problems. There were no performance problems. Everything just worked. And they had been testing it the whole time. Every sprint was a demo of like, hey, things have gotten better. Here's our state. And they would just bring up, they had like test phones in the office. Like there's an iPhone and then there's an Android phone. And they would just load up the mock site, and they passed the phone around. Everybody could play with it and be like, oh yeah, this is super cool. But it was because of that early phase doing exactly what you just said of build it first and improve on it as it needs to be improved.
Yeah. You also kind of alluded to another thing that's rather important with this. And we've kind of alluded to it the whole time, but having the business people involved too, right? So you said there was some product owner that came in and said, hey, it has to perform in this way. And we want to deliver it in this time frame. But if you have it deployed, that's the other thing that I learned, especially as a freelancer. I can't tell you how many times I'd get a requirement from a business person. I'd go and I'd actually start building it. And because I was deploying frequently and I was deploying from the get-go, as soon as I had something, I'd send it over and say, it's not done, but this is the direction I'm headed. And they'd come back and say, oh, well, I don't really want this. I want this. Or, hey, we need to tweak it this way. Or I'm a little surprised that it does this and not that. So that's another benefit of this too, is that the people that really have a good feel for where things need to be at can come in and look at it. Another example of this is, so I just quit my job at Morgan Stanley. I'm picking up a contract somewhere else. But on the project that I'm working on, we're dealing with a whole bunch of compensation financial data. And, I'm not an expert in this stuff. We're building a report engine right now, and I'm hoping to have it at least somewhere close to, hey, you can finish this on your own before I go. But, it's the same deal, right? We keep going back to the business people because they understand the customer. They understand the data that needs to be there. And so by having this, you get that kind of feedback too. Not this. Oh, we need this different. Don't display data, right? Because we're dealing with like salary and stuff is personally identifiable information. So it's protected under law. And so it's like, well, if you have 3 or fewer numbers that go into the report, then you don't display it, right? But 4 or more, it's on the average or the aggregate. You can kind of get a picture of where it's at, but you can't actually tell who's getting paid what, right? So it's that kind of stuff where they're going to come back with the regulatory stuff and the user important stuff and all that other stuff. And so by having all this stuff, you get the conversations with everybody else too, is my point. And then just to add on top of that, the other thing that I advocate for is some form of continuous integration, continuous deployment. And so as you improve this thing, you need to constantly be testing it, but having that automation behind it where it goes, oh, this is broken. We assumed that this was going to work this way, and it doesn't work this way, right? Because sometimes you miss stuff, right? As the system gets more complex, it's real easy to do it. And so as that gets added in and this gets added in and the next thing gets added in, just having something that's just a quick sanity check on it, right, is very, very helpful. And so, I advocate for that too. And Ben's talked a whole bunch about engineering practices and testing on the ML side, but it's just as important on the other side. And for fast tests, you can mock out the other side, right? Or you can use a system. There are different libraries and different languages that effectively you can tell them, hey, just capture the return, whatever they give you back and save it in a file in a structure that you can replicate. And then you just tell it, hey, every however long, delete the recorded response and get a new one, right? And that way it continually checks to make sure it's valid, but you only get that long, hey, I'm waiting for it to get back to me, and then, reacting to it, because everything, the rest of the time, it just picks it up on a file off of the system. And then you could do the full end run integrations nightly or however often, or, once your fast CI runs, your slow CI can go however you want to set that up. But then you get those sanity checks on a regular basis. You have it deploying, right? So that if there's a problem with it building or deploying or anything else, if somebody detects a problem in your staging system, all of these things are canaries in the coal mine that lets you know there's a problem well in advance of when you actually have to get this thing out. Hi, this is Charles Max Wood from Top End Devs, and lately I've been coaching some people on starting some podcasts and in some cases just taking their career to the next level. Whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships, and how to build their careers and max out and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching.
Yeah, and totally. And that idea of applying CI to ML it's done in a slightly different way than it does for traditional software development, just due to the time involved in build. You can't just rapidly build your software. Models take time to build, but that doesn't mean that people can't be like, well, we're data scientists or we're doing ML. We don't need tests. The exact opposite is true. For the exact reasons why you said a CI is so important in front-end development. When you're working on a project that gets as complex as working with serving recommendations to an app or a website, there's a lot of minds involved in crafting how that path of that project is going to be released. And whether it's from project managers or the business unit that is interested in that recommendation, or it's marketing, or you could have 24 people at the company who are in positions of authority above engineering and ML who are saying this needs to function this way, or hey, I don't like that, change it to this. every single one of those changes should be validated through CI and through tests.
Yep.
Because if you're not, and you're just waiting for, well, we'll do testing when we push it to staging 2 months from now. Who knows if you even implemented all of those like the business expected? Because that's going to piss them off, something fierce. If they've demanded something, you said that you implemented, but you actually forgot to, or you didn't do it correctly.
I've done that before.
Same here.
I've done all of those before, right? Where it's oh, I forgot about that. Or
we'll get on that today. Hot fix.
Yeah, or I got it done. No, it's totally done. And then they go look at it and they're like, this is not what we asked you for.
You're like, oh, I forgot to merge that branch.
Well, but that's, again, back to that rapid feedback idea.
Yes.
Anyway.
Yeah, the continuous validation. If that's not happening through both CI and getting it in the hands or getting eyes on it from the person who is really interested in that project, the complexity of the implementation is going to grow to such a degree that it gets where I've seen a lot of data science projects get. Because company calls up to get some feedback on a project. They're like, hey, we want to know if this is ready for production. You kind of look at it. Now I see why you don't have unit tests, because this is actually untestable code. There's no way to test this. The operation completes only when the output comes out. So yeah, it becomes like this gigantic bowl of spaghetti code that's in this repo that everything's relying on side effects, and there's no decoupling of any instructions because nobody was testing it all along. And then when something doesn't work the way that the business wanted, it becomes a finger pointing game. Data science blames front end blames data science. And it's like, hey, you gotta get them involved early, the business people, and get feedback.
Yeah.
And test everything.
Now the thing is, and I just want to go and kind of push on this, because I'm sure somebody's listening and they're going, well, you're talking about having it deployed and getting CI and CD. What does that have to do with the front end being able to talk to the ML system? And realistically, it will solve so many of your problems between the two. And it's funny because it seems a little bit counterintuitive, I think, to people to kind of look at it and go, well, how does testing the front end code going to solve issues with how it integrates with the ML or data science or whatever system? And the reality is there are a couple of things that it does for you. One is, yes, you can test the integrations, but the other thing is basically what Ben said. Sometimes if you go and you just write the code, you're going to wind up with code that is exceptionally difficult to test. And if you can test the individual pieces, right, where there is a side effect or there is a return value or there is IO or some other thing, and you can break that down so that you can test it, you also break it down so that you can actually troubleshoot it. And that solves so many problems. And so then you just understand, hey, it's this piece of code that has to talk to their stuff, right? It's not the whole app. It's not this big complex mess. It's just I have to understand this piece when I'm talking to them about their piece.
Yeah, exactly. And from my experience, it's been a mixed bag of implementations that I've seen that go through the fuzzy boundary between systems. I've seen companies or teams, these cross-functional groups where they're like, hey, we're going to have 10 front-end devs working with 5 data scientists and 3 ML engineers, and hey, build this project that is actually going to be customer facing. And it's interesting to see how some of the more smooth transition development processes that I've worked with do it, where there's integration tests running on the data science side that the ML engineers have written that push the data to some like a NoSQL engine or RDBMS, but then there's a test that'll actually call the nightly build branch of the front end code and query what they just pushed,
right?
And assert that matches. And I've also seen that other front end team on their nightly builds mocking up by pushing the data they expect into that NoSQL engine and making sure they're getting a return that they expect. And it's really interesting to see that blurring boundary between this data storage layer, where it's like, this is how Like, is it overkill? Maybe. But when you think about it, there's no way you're going to sync up those two teams' release schedules in a sprint.
Yeah.
Unless you have a sprint, release branch or something that you're using and you're using Git flow in that way. But most teams don't work like that. Some things.
And it's often a headache to coordinate that. So.
Oh yeah, it's a nightmare. So being able to like blur the boundaries and be like, hey, we're going to test some of your stuff and you're going to test some of our stuff, so that we're making sure that we're doing the same thing and that we're always translating between what we're producing and consuming.
Mm-hmm. Well, and just then on the other side, level testing, what's the purpose of this? The purpose isn't to get it in the database. The purpose is to get it to the other end.
Yes.
That's what I like about that. Can the other end get it?
Yep. And then there's another component that some teams don't even think about until they're already in production, which is measurement. People are like, well, we released it to production and everything's great. It's serving recommendations, or it's serving, next best action to the site or the app. And I never like to be the one asking the question, but I always ask it. I'm like, so what's next? How are you going to determine how to improve this? And they're like, oh, well, we'll see the revenue go up, or we'll see engagement go up. Like, how do you know what somebody clicked on, or which one of these elements in this frame? That frame is new. So it's not like we have ETL set up to capture that activity. Front end, they're obviously going to log all of that for the most part. I've only seen a couple of teams be like, whatever, we don't need that.
Well, that's the other part of the conversation too, is we want to collect this data so that we can improve this, that, and the other.
Yep. And then that's another conversation between the data science team and the front end team to talk about how they're going to collect that. And when you're talking about mobile apps, it gets a little hairy. What happens when somebody goes out of signal range? Are you going to cache the state of interaction so that when they come back and get signal again, it's going to do a dump to our streaming service? How are we going to get that information? What if somebody kicks off their internet and then closes the app and that data is lost forever? Well, we have an acceptable rate of loss of this that we can't see how somebody interacted. But all of those details are best served through talking about a different sort of customer creator or customer producer model. Now it's not the producer is the data science team and the front end is the consumer. It's the opposite. Front end is producing and data science is now consuming that. And the exact conversation needs to happen that happened at the beginning of the project the other way, which is, what data structure do you need? How do you need this data? What do you want it to look like? And the front end is going to be your best friend for dictating what that structure is, making sure that you're collecting the data that you need to answer those problems.
Yep. Well, and I mean, you really just broke it down exceptionally well. I kind of want to change tactics a little bit and talk about the actual communication between the two, right? Because it sounds like there are multiple ways to do it. We kind of talked about the back end just says, hey, give me the data, and the machine learning system gives them back a data structure they can read, right? So they format it as JSON, or they give them some other structure that the system can read. But it also sounds like maybe there's some other layer in between, right? Where the machine learning system generates the recommendations or results, whatever results they're going to pull, and then puts them into like a separate database. And that's the data source for the front end. I mean, when do you pick one versus the other? And are there other approaches that I'm not thinking about?
There's basically three primary ways of sort of producing predictions after you have a trained model. One is sort of scheduled batch, and that's what we talked about with recommendations. That's the traditional recommendation engine. And the reason you do that is because the models are so large and so complex and take so long to train that you just predict more than what you need and make sure that you have enough content that's generated in the bulk prediction extract. And you just store it somewhere that the front end can query. And that's traditional database, NoSQL, graph database, if that's your thing. You just put the data somewhere that is consumable through just a query paradigm that they can use. Then you have sort of a pseudo real time where you'll have a model artifact, but maybe the data is of such a volume and you don't have an SLA that is extremely short. So to reduce costs, you might stream data through a model that's pre-trained.
Right.
And that would be using something like Apache Spark or StreamSets. Like there's tons of options out there for you to just use Kafka or Kinesis or Event Hub and push a stream of asynchronous data through a model and get predictions out the other end. You're usually reading it from Object Store in the cloud at that point. You can throw a REST API around S3 or ADLS, and the front end can query that. That's usually for internal tools, is what I've typically seen. You really don't do that for customer-facing apps.
Right.
And then you have the ultra-low SLA where the model it's lightweight enough and the predictions are super fast through it that you don't have to pre-calculate anything. You just host the model. Mm-hmm. And that can be in a Docker container. If you're on one of the cloud providers, using like Azure Machine Learning or SageMaker, you can run that container as a service and they manage it for you, for better or worse. Mm-hmm. And then you have the sort of ultra low latency implementations that you need where like, hey, we have an SLA budget of 5 milliseconds. We know the model, if we're just taking one record of data through this model, it might take 3 milliseconds to get a prediction. Maybe it's a linear model or something.
Right.
But you need to serve that at massive scale. And you need to have your 999 performance to be always less than 10 milliseconds, for instance. Then you're looking at containerized deployment in infrastructure that can support scale like that, where you're like, all right, we're creating a REST API and it's running on Kubernetes, and we're going to just create, we're going to allow elastic scalability up to 100,000 pods on this cluster. And that'll handle the most amount of volume you could ever think that it needs to handle. But in any of those situations, aside from the database, it's all a REST API interface that the front end is hitting. And the architecture of making sure that scales correctly is all on the role of the architect, like the cloud architect, and usually the ML engineering team. But I've only seen those deployments work if it's a cross-functional team, where it's the front end and that ML engineering team and the architects are all working together. And that's not, hey, let's meet once a week and show progress. It's more like, no, we're going to embed all of us in one team for the next 6 months, and we're going to build this together. Because when you're talking about scale like that, when you're hosting artifacts and you're doing real-time inference for something that's widely used and is super important and has a high traffic volume, it has to be designed properly, it has to be built properly, tested, and you need fallbacks for your fallbacks in those situations.
Yep. Well, is there anything else that we should go into with this stuff? Or
about cross-functional work, the TLDR of it is just work together. Anytime that something's going to be customer facing, the earlier that you work with the teams that are going to be consuming the data and providing it, focusing more on that and making sure that all the ideas that come from the front end are being incorporated in the ML code, which informs the design of the model solution. It's just going to benefit if everybody's working together. So invite the senior developers from the front end team to sprint planning. Invite them to the retro. If they're up for it, have them join your Scrum call every day, and make sure that you're doing all three of those things as a data science team. Like, follow their lead in agile development processes, and it will benefit your team greatly, instead of how a lot of teams do it, which is like, we just have one person working on this model, and they're gonna work on this for the next 3 months, and then they're gonna show us what they got. That doesn't work. Doesn't work when you're doing anything but academic research and Kaggle competitions. If you're doing something for real, do it like the professionals do, that write software all the time, and work with them.
Yeah, I agree. The only other thing that I would add is just make sure you understand the parameters you're working under, right? And so that should shape a lot of your conversation, right? As far as performance or functionality or expectations, because the last thing you want to do is build the wrong thing or build something that doesn't quite deliver what needs to be delivered, right? You don't want to get close. You want to nail it. And so, just make sure that you're looping in the business folks too, the other stakeholders, and make sure that they are in the loop as far as what's out there, what they can see, where you're at, any questions you have. And that way those communications can occur as well. But I completely agree. I mean, communication is the key to all of this. If you're not talking, then you're going to have problems when it comes to kind of getting the teeth of the gears to mesh in the right way so you can get stuff to go.
Definitely. That actually, what you were just saying about knowing your parameters, that reminded me of something that I saw happen at a particular client I was working with, that they didn't explain what the SLA budget was between what the business needed, what the front end had set as for the response time to the ML model. And they were doing a presentation that I was at where they're showing metrics performance between test and control. And they're like, well, we don't think the data science implementation is that good because it shows zero difference between test and control. And I was like, oh, well, how's the SLA performance on this? And what's the cardinality of unique values that get sent across in a particular day? And there was an analyst in the room who was like querying data while I was asking all these questions. And she came back with, she's like, wow, turns out over the last week, every day, every single customer saw the exact same list of recommendations. I was like, yeah, can you see if that list of recommendations that everybody saw is the same as the fallback? And she's like, yeah, that's what it actually is. That's all we were serving. I was like, what was the timing on cutting over to the fallback if the REST service didn't work? And the numbers were just configured incorrect between what the data science was expecting and the front end was expecting. So they didn't even realize that they were never actually serving recommendations because nobody had actually planned out what the acceptable budget was.
Oh, man.
They didn't relax the standards. So they're like, hey, if your records aren't ready in 20 milliseconds, we're going to serve defaults. And the records could never, for their implementation, they could never hit anything less than 80 milliseconds on a response.
Mm-hmm.
And then they changed that. They increased it to say, okay, you have 150 millisecond budget before we do defaults. And then within 48 hours, you could see this clear difference between test and control. They're like, oh, the A/B test is working. Like, yeah, because now you're actually using machine learning.
Yep. And that's the thing, right? Is it's back to having the communication and then having stuff actually plugged into each other so that you are talking about how the thing actually works, right? You have to have some form of real feedback from the system. Or, I mean, I don't know what else you base it on other than, hey, we're starting to see results from the system, right? Even if it's just, look, it works, to build on it from there.
Yep. I think you'd be surprised how many times
No,
I've seen people...
No, I wouldn't.
It's almost like lick their fingers, stick it in the air and be like, yep, the wind's blowing, our model's good. It's like, well, how do you know? You're not even collecting the data. And if you are collecting it, you're not analyzing it correctly.
Yeah. Well, that's a whole nother can of worms, right? Is the recommendation actually generating people going, oh, I wanted to watch that? Or, whatever other criteria, maybe it's not just that they clicked it and started watching it. Maybe it's that they clicked it and watched a certain percentage of it, right? Which indicates to you that they actually liked it or at least found it interesting enough to get 75% of the way through it or 10 minutes into it, or I don't know. So, I mean, that goes back to knowing your criteria, but the criteria a lot of times is, just make us more money. And that's too broad, but that's a whole nother thing. But I really like that where it's, you're not just testing your model in the sense that, hey, I've got CI running, but you're also testing it in the sense of, hey, is this yielding results the way we want so that at the end of the day, we're keeping people spending more time on our platform or, whatever other thing that you want.
Exactly.
All right. Well, I think we're down to picks at this point, but I hope this was really helpful to folks and kind of coming at it from different directions. I mean, it's a real issue. And I think a lot of times we kind of get lost in our own little silos and, hey, all my stuff runs. So, whatever. And the reality is maybe whatever systems I need to be talking to, whatever systems need to be talking to me. I should be talking to the people behind those and make sure that they're all doing what is expected.
Yep.
And
exactly.
It's amazing how many headaches. It's amazing how many headaches you avoid by doing that.
Yep. And how much you can teach each other too. That's the real beauty of that cross department work that I've seen, is those teams have a lot to teach each other at any company that I've seen.
Oh, that is so true. I can't tell you either. I mean, we run 8 or 9 podcasts every week on Top End Devs. And what's funny to me about so much of it is that a lot of times what you'll see one community invent something, and then you'll see it trickle through all the other ones. And I mean, that's the beauty of some of this cross-functional stuff, is that, there may be some practice that they're doing and you're going to go pick it up. And so it may not even be, hey, there's the benefit of we understand what they're doing, or we understand their approach, or I picked up some things about what they do. It may be, hey, that's actually pretty useful if I apply it to my thing too.
Exactly.
Yep. So, yeah. Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium. All right, well, let's do some picks. Why don't you go first?
My pick this week is something that I haven't gotten through a lot of yet, but I've always wanted to read that the series, the Frank Herbert series of Dune. Uh-huh. And with the new movie that came out, I was like, I'm a huge sci-fi nerd. So I was like, I've always wanted to read that. So I spent, I don't know how many hours looking for a non-just paperback copy of it, and went down the rabbit hole of trying to find solid hardcover copy of that. And it's pretty shocking to me how the correlation between popularity of something in sort of movie or like film or TV indirectly increases the value of certain things that they're based off of. So that was really fascinating for me, is watching what the price history was of a first edition copy of Dune hardcover changed over time. I did not buy a first edition of Dune. I did find a hardcover copy though, so I'll be reading that shortly. But it was just a funny little anecdote to see, wow, the price of this, tripled because this new the fourth implementation of that book on screen just came out.
Is it the fourth implementation? I'm only aware of like the 80s movie that was like 18 hours long or something. I think it was legitimately. It was like
they had like the
4 or 5
the 80s movie, and then
there's this one.
I think there were 2 miniseries that they did.
Oh, interesting.
I'm pretty sure there was 2 different ones. One was really bad. One was pretty good. But then this new one is, I haven't seen it yet. I'm going to read the book first.
Nice. Yeah, it's on my list too. The book series that I'm in the middle of is, and this is because the last book in the series is coming out, tomorrow? Today. Comes out today. The Expanse.
Oh.
That book is...
I've got the first 4 books over there.
Audible. I pre-ordered it on Audible, so I've been listening to it. So I'm on book 5 or 6, I think, right now. Nice. Babylon's Ashes is the title of the book. I don't know. I always just tap, okay, play the next book in Amazon or in Audible, right? I am going to pick a few things here that I've been doing. One thing that I think is interesting is you started going down the path of, I was looking into hardcover books, and I'm going to hold this up so you can see it. Our audience can't. But this is a leather-bound book. This is The Well of Ascension, which is one of Brandon Sanderson's books.
Ah, nice.
And yeah, he sells them on his website, and they're collector's items. Mine are signed, but it's funny because, I mean, you can go way down the rabbit hole on some of this stuff.
Oh yeah.
Not just the hardcover, because these are technically hardcover, but just the quality of them is pretty amazing. And then beyond that, I'm going to throw out a few other picks. So the book I'm reading right now is Traffic Secrets by Russell Brunson. Now, when I go run, I typically will listen to an audiobook or a podcast, but mostly it's an audiobook, and it's usually like a business book or something. I'm still working through the 360-degree leader just because my whole exercise routine got thrown off, and so I got to go pick it up again. And I'll talk about that in a second. But yeah, Traffic Secrets has been awesome. For board game pick, I'm going to pick Steampunk Rally Fusion. It plays up to, I think, 8 people. And effectively, the way that works is you build a machine that is supposed to, you race with it, right? So the board is a racetrack, and you have a little marker on it. And then you have cards that are your machine in front of you, and you select machine parts, and then you roll dice to activate the machine parts so that you can move down the track. And it is a really fun game. As far as complexity goes, I probably ought to tell people, right? Because I've picked some games that are pretty involved to set up and play. This one is not so involved. It's slightly to moderately involved. So, if you like kind of the games where there's a little bit of setup, you kind of have to read through the rules in order to get it, but read through the rules once, maybe twice, and then you're ready to play. And the gameplay is like 2 or 3 stages per round. This is one of those games. It's not that complicated, and you're really only doing 1 or 2 of a couple of actions. So
I just looked this up online. Is that 24 die for each player? I just see this massive pile of 6-sided dice.
So there are a zillion dice that come in the box, but they all just go into kind of a pool. And then, you just, you pick up the dice that you're rolling that you've earned, basically, and then you roll those, right? So there are a whole bunch of different colors. And when you play cards, you get dice of specific colors. And so you may pick up like 2 red and 1 yellow and 1 blue, and then you roll them, and then you place them on your machine parts to activate them.
Got it. That sounds pretty cool.
So yeah, if you look at the picture, I'm sure there are like a bazillion dice, and they're the bigger dice that are you can roll bigger numbers with, is the way that those are set up. And they're kind of wild, and you earn those in specific ways too. So, but so I think there are probably like 60 dice or 80 dice in the whole game, but it's awesome. And so you have a scientist with your machine, and so they've got scientists and pilots and people like that from like real life that they've named their characters after. So anyway. It's a super fun game, so I highly recommend that. And then lastly, I'm just going to remind people, Top End Devs, we're doing our launch. I've extended. I was going to do a Black Friday deal, but for heck's sake, I mean, my birthday, right? My birthday is December 14th, so you can sign up all the way through my birthday for the pre-launch sale. It's 50% off for your membership. And we're working on getting the content engine rolling, putting content out for folks. So you can kind of come see what series we're putting together, and what courses we have planned over 2021. And then I'm working on recruiting people to start putting together some of the other content for Top End Devs. But what's interesting is that as I've talked to more and more people, it's really become apparent that what people want, and what the part of it that I wanted to provide beyond just the courses and stuff, is really what people are getting excited about. And that is that you really can't advance your career the way that people want to advance their career without involving other people. And so we're setting up a Slack channel. I'm putting a forum on. I was planning on doing all this anyway. I'm probably going to start running the meetups in January or February. We're going to start doing summits, online summits, but I'm going to do them different from how you're probably used to in some of the other places that you've done it. Because usually what you wind up doing for the online meetups or online summits is you show up, you listen to the talk, and then you sign off. And so it's mostly just a webinar or series of webinars. But I really want that interactivity. And so we will have stuff going on in the Slack during those. But then we're also going to, as part of the meetups, or in addition to the meetups, I'm still figuring that piece out, we're actually going to have networking sessions. And so you'll just get on. We'll probably run it through Zoom or something similar. Zoom has breakout rooms, right? So you just assign random breakout rooms, or we might say, hey, look, we're doing a networking and we're going to let people pick 6 topics. We'll vote on them, and then we'll set up breakout rooms for those. And then you come and you can talk to other people about them. Things like that, where you can actually come and interact. because at the end of the day, I mean, that's what's gotten me ahead. That's what's gotten a lot of other people ahead, is that they figure out a way to get to the place where they can go meet people. And then from there, then they're enabled to get a referral for a job, or they learn a thing from those people, or those people open doors by introducing them to other people, or any number of other ways. So that's what I'm doing with Top End Devs. That's going to be a major focus. I feel like that's an area that is neglected by a lot of these others. And then if you can't make it to the networking sessions, I'm also implementing Donut on the Slack. And so what you can do is you can go into the channel, the networking channel or channels, and you can actually just tell it that you want to meet people. And then what it'll do is it'll match you up with somebody else, and it'll help you connect. So then you can just jump on a call for 30 minutes and go, hey, I'm so-and-so and I do such and such, right? I do machine learning and I'm learning this, or, hey, maybe I'm a student and blah, 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 right? But you can go and you can meet other people in the community, because if, as much as we can enable that kind of thing, I think we open up all kinds of opportunities for people to go contribute to open source, get inspired to go mentor people, or get the help that they need to kind of get up the chain. So anyway, go sign up, topenddevs.com. And like I said, up through December 14th, it's going to be half off. And then after that, then it's going to be full price. And that gets you access to everything. It's a full membership. I'm not sure if I'm always going to run just one level of membership. I might pare it down and, hey, the summits are another level. But if you sign up here, you'll always have the full membership that includes the summits and everything. So this is your chance. I don't think I have any other picks. So let's go ahead and wrap it up.
All right. This was fun.
It was fun. All right. Well, until next time, folks, Max out.
Later.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.